Good afternoon. We are addressing number 6 problem, which is indoor air quality. We come up with a solution to power microalgae air quality improvement system. My name is Marco Favela.
My name is Luis Castillo.
Gabriel Marina.
Daniel Rios.
My name is Luis Mota.
My name is Jorge Henrich. We are mechanical and aerospace engineer, and our team is Invent.
Vision. Current air quality in cities like Ciudad de Mexico, Monterrey, Shanghai, Detroit, it's deplorable. There is a high health image or health accomplishment like damage in respiration system, headache, nauseous, and zero power because air quality try to solve all these problems, and a part of that implement benefits like improving concentration in doing tasks, cellular regeneration, and stimulate the immunologic system. Which we want to do all this, introducing clean air in houses or indoors. The vision of the project is try to be one of the most clean air producers, and want to introduce this clean air to houses and different companies like apartment markets or any building that need clean air.
For background, many people think air that we breathe comes from trees, but the oxygen, most of the oxygen, is produced in the ocean. So we are going to take advantage of that little bacteria called phytoplankton or cyan bacteria that produces a lot of oxygen and cleans the air, and introduce it into the living houses of all of us. We are going to use for our project the cyanobacteria Chlorococcus, which is one of the most common bacteria in the ocean and is in latitudes between 40 and 40 north and south. We can use in different environments to produce oxygen. It has a low rate of oxygen production. And just a comparison, so you can see an average 30-meter tree, which is pretty huge and consumes a lot of water, produces 2,000 kilograms of oxygen in a year. But our system that is 2 meters high produces double with 1/10 of the water. So the only things that we have to consider is to keep the pH of the water and the temperature so the bacteria can grow. We can also add nutrients to improve the production of oxygen and consumption of monoxide carbon and oxide natural.
The same requirements, we want to minimize the electricity consumption. Also, we want to have a zero waste. Also, we want to improve the air quality by decreasing the CO2. We want a low-cost product compared to other systems in the market. And we want a system that has an easy installation and an easy maintenance. We have here two products, the Biomitech reactor and the Honeywell bioreactor. These are kind of useful, but they use a lot of electricity. For example, here, 58.3 kilowatts per hour. and both of them have a high cost. Also, the second one needs a lot of space. We have here our first prototype. We have 3 subsystems: a production system, a recirculation system, and a waste management system. And we have here our final design and its engineering drawing.
Okay, just to recall that these bacteria produce oxygen by photosynthesis. So in days it produces oxygen, and at night it produces carbon dioxide. So these green pipes are used to store the bacteria to produce the oxygen. Okay, so this is in this view we can see that this side is the building. So we are intent to extract the air from the building and then pass that air through the system to incorporate the oxygen, as well as release the carbon dioxide and also monoxide, and then restore it to the house. And at night it will go to outside from this other path. And also we have a waste treatment system. So in this case we need to change the water periodically. So we are going to use that Y valve, and also it is intended to be automatically.
So one of the most important specifications for project is the power consumption. So we took into account all the components, the electrical components of our project, and we made a cost estimation and consumption estimation, and we got an average of 55 kilowatts per month, which is a great number compared with the competitors. Also, we have a flow diagram which helps us to understand how the electrical system works. And here we have basically all the components that we'll need to build this project. I'm talking about components such as sensors, relays, displays, power supplies, etc.
Well, we have a table with the bill of the materials. Basically, that is all the materials that we use for make a prototype. And we need to have in common that this, we search this in retail, and the cost of this is $450. But we can lower the cost if we buy all this in wholesale, because we search like the things in Amazon and things like that is more expensive.
For the installation of the bioreactor, we'll need a plate, a white plate preferably, and we'll install it either in the roof or on the wall that receives sunlight. And it's white to reflect most of the light, so that the heat doesn't go in the bottom, and it creates more oxygen due to the reflection. The maintenance has to be preventive every 3 months, and automatically every 3 weeks. We'll do that with an automatic system, as my partner explained. And the point of doing the maintenance is to avoid corrosion due to bacteria staying in the tubes. And also, we'll try to keep the levels of the bacteria in a certain level, so we don't generate like Red Sea.
Okay, basically what makes us unique. We have a low cost compared to the competition. Our model is modular, so it makes it more simple for manufacturing and maintenance. Our waste management system is that we can sell the waste to another company and provide zero cost to the client. And our ability is that we can implement this all over the world. Our project can be made because it's simple in design. It uses available materials, and it has a safety factor, so it can produce the amount of electricity that the amount of oxygen and clean the air that it needs. Future developments, where our company or project is going, is that we can search more microbiology. If we implement a large-scale manufacturing, we can decrease a lot the cost. We are looking for a neutral carbon footprint, and also a fully autonomous water treatment system, so it decreases the costs. In conclusion, quality air has a huge impact on our lives, and our products achieve it by using the power of the ocean. Questions?
All right, we'll start with Dr. Baez.
So is this a capsule project?
No.
No? Oh, I thought that you were guys working on a capsule. So what are the basic parameters to keep algae alive? You said pH levels.
The water temperature, also the concentration of, in this case, nitrogen, phosphorus, potassium,
Right.
the light of the sun, and the concentration of the bacteria, that it doesn't go over the air.
Where do you plan to locate these?
We are planning to locate this on the latitudes between 40 north and 40 south, which is where the bacteria lives naturally. And, I'm sorry.
In the house?
Yeah. In
What part of the
houses,
house?
In the roof, or it could be in the outside of the walls. You know, some places where the sun is easily to achieve the system.
Yes.
What kind of analysis about the risk of constant situations can be about that kind of environment things that you're working right now?
I'm sorry,
Because you're using the something to combine in order to get a new item, right? So how do you make sure doesn't impact to the environment or the human too?
oh, we need some pretty basic calculations on the average oxygen a person breathes through the day. We did an average for 6 people in a normal household, and then we calculated how much algae we would need to generate that oxygen. And we also added a safety factor due to algae doesn't produce 100% of that oxygen. That is why the two are that measurement.
And we can also take into consideration that this algae not only introduces oxygen to the environment, it also gets rid of certain molecules that can harm the people. So it's also helpful like CO2, carbon monoxide, and nitrogen oxide, among others.
Dr. Baez.
When you started, you had pictures of these horrible plants spewing smoke. Does this help with that? I'm having trouble visualizing how this is helping solve that problem.
Well, it gets the air from the atmosphere, so it gets the CO2, which is most of what we produce today, from there, and then put this inside your house. Because our trouble is to have good quality inside buildings. Then we can figure out what to do with the environment, because that has to be a large scale project. We're trying to do something inside buildings so you can breathe better.
Dr. Garcia.
Did you calculate, I'm presuming that you're taking air and the algae will absorb some of the pollutants. So have you calculated the amount of area and the power needed to circulate house air through a liquid full of algae?
Okay, well in this case, in this case, we are assuming that the green pipes are going to contain the microorganisms. So, well, the algae. So, using a water pump, we are pretend to, yeah, right there, to elevate the
Bubbles.
yeah, the bubbles to
Right, so you're gonna bubble the air.
Yeah.
So is there, how much power and what's area do you need?
Okay, yeah, so the water pump, in order to pump all that amount, we took like a water pump from Amazon, and it was sufficient by the amount of liters. Actually with one pump we could generate sufficient bubbles and sufficient airflow, so we saturate the system with air, with the pollutants. With one pump we can simulate
The
both.
one pump is like for 300 gallons, so it's still core for the whole
We are using-
pipes.
We're using 8 liters, so it's
8 or
80.
80.
Yeah.
So the goal is for near to.
And also, as it is just 2 meters, it doesn't have that much pressure.
That's 80 liters of water on the roof.
Yeah, but it's distributed
40.
along 2 meter by maybe 1 meter square, so it's really distributed like someone laying down on the roof.
How would you prevent other microorganisms from getting into the system and starting to grow? So like if you had, so you have a particular organisms, the algae you want to grow, how do you make sure that nothing else is going to get in there and start
Actually,
getting all the food and start reproducing? It might cause some kind of a problem.
yeah, actually that's a very good question. And the thing is that this algae, it's very good to generate oxygen, but it's very bad for the environment, like for the ocean. It kills a lot of fish, they generate toxins.
Yeah, they did.
But the waste that they generate, like I think the nitrogen oxide and like the dead cells are really good for fish. So in a very saturated place, like in these tubes, they're going to kill anything that goes through those tubes. And the waste that manages through here, that waste, because it doesn't have like the live bacteria, you can use it actually to feed fish. That's the thing, that we can use the waste to sell it to other companies or for different purposes. So if we don't affect another part of the ecosystem, but actually like the problem by just doing a patch, because of what was our first design, doing a patch of this on the sea. The problem is that it will affect the organism of the sea. So by doing it in this closed system,
Yeah, that is why in the ocean sometimes there is like the Red Sea, because most of these kind of bacteria overpopulates, and then the oxygen and the light doesn't go over the water.
Yeah.
Fish start to die.
And
Let's say hypothetically a hospital used this. Do you think that it would be something they'd want to use? Do you think it would cost more than alternatives?
Well, there is not a good alternative for producing oxygen cleanly without overspending that much power. We are spending 51 kilowatts a month. And for example, the other one we put in the example is spending like 200 in an hour. So for the hospital, it will be like, well, they have to be really concerned about the safety. However, they will spend a lot more less money.
So the concern would more be safety than cost?
Yeah, safety, because they have to do maintenance. They just can leave the working by themselves.
yeah, and the thing like for hospitals, I don't know, like this is a hunch, but I think they use more rich oxygen. Like I think that for surgery they use like almost 90% oxygen or something like that. And our bacteria doesn't do that. What our vision is that this bacteria can be used in an office setting, on schools, and it has been documented that a rich oxygen environment and clean environment can actually help with cognitive tasks and also productivity, also with mood and a lot of health factors. So yeah, it can be used in all those other settings.
That's all the time we have for questions. Thank you.